Hi all, welcome back. We're going to go over digital audio files in this part with some examples. So to start, audio files usually have one channel, which is called mono, or two channels, which is called stereo. And those two channels usually correspond to a left speaker and a right speaker. And so a stereo audio file will have two waveforms, two streams of information, one for the left channel and one for the right channel. Stereo sounds way better. We'll see that when we get to actually mixing. I'll demonstrate the difference between what mono and stereo sounds like, but just trust me on it for now. The other thing we need to understand about digital audio files is compression. So WAV files store audio data uncompressed, and they can take up a lot of space. So a full concert recording of one audio track could take up maybe a gigabyte. Now with 16 tracks on a 16-channel mixer, that could be a 16 gigabyte recording. And that can get pretty large. So there's two ways to compress that. Lossless compression loses no data, but it's able to achieve compression ratios of around 50%, which is pretty good. So if I have a 16 gigabyte concert recording, I might be able to get that down to 8 gigabytes. Lossy compression fundamentally changes the audio, but it does it in a way that's imperceptible to most listeners and can achieve compression ratios of 1%. So streaming services by default, and some of them only serve lossy audio. So YouTube, for example, only serves lossy audio, and Spotify by default serves lossy audio. They recently rolled out lossless streaming, but because it can compress so much more, for example, that 16 gigabyte concert recording could get down to maybe 200 megabytes with lossy compression. It can save a lot of bandwidth, but fundamentally it loses data. And so we never want to use that for mixing and mastering, except to send drafts. Maybe sometimes if there's a file size limit, like on Discord, I want to send someone a draft, I'll encode it using a lossy codec. But otherwise, you want to use lossless compression for everything, or uncompressed audio. And that's going to allow you to mix and master without losing any information in the process. I personally use FLAC for lossless compression, and yep, it achieves around 50 to 60% compression ratios. So let's look at some examples. But before that, one last note. When YouTube, for example, encodes your audio using a lossy codec, it changes the data. Like it's not the same waveform that was put in, but it should sound the same. However, one time where that might not be the case, remember this digital clipping we wanted to avoid. So let's imagine you made a recording and you limited it and exported it such that it peaked exactly at this red line, that maximum possible value. Okay, and that's great. It'll be loud and you're using the whole dynamic range. But when YouTube converts this uncompressed audio, transcodes it into some lossy codec, it's going to actually change the data. And that peak that was 0 before, the maximum value or the minimum value, say, it could actually be changed such that it goes above the maximum value or below the minimum 0. And it could clip depending on how the algorithm handles that. So that's one thing to keep in mind. We want to keep some headroom here. We never want to push our levels all the way to the maximum or the minimum, or else we might encounter clipping during transcoding. So now with that out of the way, let's look at some examples. So this is an example of a file. It's a mastered track that I did, and it's a FLAC file, so it's losslessly compressed. And we can see here it has a sample rate of 44.1 kilohertz. It's in stereo, so it has two audio channels. And this S16 tells me it is a 16-bit depth audio file. So this is good for listening. And let's take a look now at another similar recording, but this time it's a WAV, so it's uncompressed. And we can see this came straight from the recorder. It's one of the audience recordings for Minecraft. And the audio stream here is 44.1 kilohertz. It's two channels, so it's stereo. And again, we see S16, so it's a 16-bit recording. Now let's take a look at the mastered version of Minecraft. This was a mastered render that I did. It's a FLAC file, so it's losslessly compressed. It has a sample rate of 48 kilohertz. The reason being that audience recording was 44.1, but all of the other tracks were recorded at 48 kilohertz. So I decided to upsample to 48 kilohertz to preserve as much information as possible. It was recorded in stereo, or mastered in stereo, I guess. So it has 2 channels of audio, and it's a 24-bit recording because most of the underlying tracks were recorded in 24-bit, and I wanted to preserve that. Our last example, this is an Opus file. So this is a lossy codec. I think I was sending a draft of this to someone over Discord. And so we can see it was rendered at a sample rate of 48 kilohertz in stereo. And you'll notice there's no bit depth. That's because lossy codecs don't always have a bit depth. They have some algorithm underneath that might have a variable bit depth to save space or something like that. So if you don't see a bit depth when you're trying to render a lossy audio file, don't worry about it. Usually it'll have some kind of quality option, and you can say like 1 to 16, like 16 is best quality, 1 is worst. And you can make a trade-off between how high of quality the audio is and how much space it takes up. So that's all for this part. See you in the next one.